Today, 14 years into realization, celebrating the official start of machine assembly. Despite the challenges of the COVID-19 pandemic, we have managed to maintain critical activities on the worksite, including the reception of a number of ITER's exceptional, first-of-a-kind components. In March, the European domestic agency, Fusion for Energy, put the finishing touches on ITER's assembly theatre. A vast hall for preparing, then installing machine components. In April, the first two toroidal field coils, superconducting magnets weighing 360 tons each, arrived from Italy and Japan. In May, the 1,250-ton cryostat base, supplied by India, was successfully positioned in the tokamak pit. Late June, the first ring-shaped poloidal field coil procured by Europe arrived from its manufacturing site in Hefei, China. Russia and the United States are also progressing in the procurement of critical path components for ITER. Finally, the first sector of the ITER vacuum vessel shipped by South Korea has arrived on French soil and will soon be transported along the ITER itinerary to the worksite. The buildings and infrastructure needed for first plasma are 75% complete, and the pace on planet ITER is picking up as machine and plant components arrive from the 7 ITER members. The time has come to put the world's largest puzzle together, the assembly of the ITER machine. Following the spectacular lowering of the cryostat base, the further assembly of the ITER tokamak will proceed in a bottom-up fashion. Machine installation will continue with the lower cryostat components, the lower thermal shields, and the temporary support structures for poloidal field coil number 6. A set of spare pre-compression rings are the next in line, followed by the central support structure and the 18 gravity supports for ITER's huge toroidal field coils. Thermal shields that will help protect the superconducting coils are attached, and finally, poloidal field coil number 6 is lowered into the pit, followed by poloidal field coil number 5. In order to prepare for the arrival of the pre-assembled vessel sectors, an inner support column, a work floor, and 7 radial beams are put in place to stabilize the structure during assembly and welding. While the lower cryostat components are being assembled and welded in the tokamak pit, 2 giants are standing in wait in the adjacent assembly hall. Standing 6 stories high, the purpose-built sub-assembly tools will suspend each of the 9 sectors of the vacuum vessel in turn, while thermal shield panels and toroidal field coils are rotated into position. By the end of this year, the first completed sub-assembly will be transferred to the tokamak pit. 8 others will follow. Last in line is the 18-meter tall central solenoid. The powerful electromagnet will be the last major component to be installed in the machine pit before the cryostat is closed up. In all, dozens of custom tools will be required to assemble, lift, and finally maneuver ITER's super-sized components. The tools will have a range of lift capacities, 500 tons for the upending tool that will turn vacuum vessel components from horizontal to vertical, and 1,500 tons for the heavy lift cranes that will carry all major tokamak components into the tokamak pit for assembly and welding. There, the in-pit assembly tool will support, align, and stabilize the vacuum vessel sub-assemblies as they are joined and welded. This colossus can support a nominal weight of 5,400 tons. The precise alignment of ITER's largest and heaviest components to within tolerances of 2 to 3 millimeters is essential to the successful operation of the machine. Assembly sequences have been planned with this in mind and will utilize sophisticated optical metrology techniques at each step of the assembly process. The closure of the cryostat by late 2024 will mark the end of the first assembly phase. The ITER machine will undergo 1 year of integrated commissioning and testing, culminating in first plasma at the end of 2025. Beyond its symbolic importance, ITER's first plasma will be an important trial run for the machine, a first occasion to verify the correct alignment of the machine's magnetic fields and the correct functioning of key systems. The very first low-power hydrogen plasma, lasting only a few milliseconds, will be followed by other shots of increasing power and duration. This shakedown mode, lasting a few months, will be followed by a shutdown phase, during which key systems for hydrogen and helium plasmas at nominal power are installed inside the vessel, such as the blanket, the diverter and in-vessel coils. These components will be introduced through dedicated port cells in the vacuum vessel, requiring a whole host of custom-made tools, work platforms and cranes. The world will be watching as decades of planning come to fruition, and the ITER tokamak is assembled from components shipped from all around the world by the 7 ITER members.
If you like my channel, subscribe it for more videos. Bye bye.